Our solar system formed from a giant cloud of gas and dust that collapsed in on itself. But what caused this collapse? Why are planets round? And how do planets get their atmospheres? We can answer all of these questions and more by studying Mercury, the smallest planet in our solar system. We're going to find out exactly what happened to it and how it got here. Welcome to my channel. Let's start at the beginning. 4.6 billion years ago, when the solar system was just a big swirling ball of gas and dust, there were no planets yet, but there was definitely Mercury. Okay, so let's call this big ball of gas and dust that eventually becomes Mercury's proto-Mercury. Proto-Mercury started off like any other protoplanet, hot, molten, and very, very heavy. As the material collapsed in on itself, it heated up to around 8,000 degrees Celsius. But even though it was super hot, it was also very volatile. There was lots of material flying around everywhere. And this is where Mercury's journey from planet to space begins. This ejected material made its way into space and became Mercury's exosphere, kind of like Earth's very thin upper atmosphere. But Mercury's story doesn't end there. You see, Mercury's gravity wasn't strong enough to keep all of its material close to its center. Some parts of it escaped into space altogether. Over millions of years, though, this debris started to come back down to Mercury in the form of meteorites. Mercury began to grow. It gained about 1% of its current mass this way. This process is called accretion, and it helped make Mercury bigger than it was originally. Okay, so we know that Mercury was hot, very hot, but also cold because some of its material ended up in space. So now, let's add another layer to this onion. Mercury had a lot of metals in it, like iron and magnesium, which have low melting points compared to other elements. And this is important because it means they turned into gas before the rest of Mercury did. These metals then floated up to the surface of Mercury and created a layer of metal on top of the planet. This layer acted like an umbrella, blocking most of the intense heat coming from the planet below. But it couldn't block all of it. Some of the heat still came through and melted some of the metal. So these metals flowed out of Mercury's magnetic field and into outer space. And Mercury got a little bit smaller while the sun got a little bit bigger. This process of losing material to the sun is called sputtering. It's thought to be one of the reasons why Mercury is so dense. Sputtering is also responsible for the fact that Mercury has no atmosphere. All of the elements that could have formed an atmosphere were either blasted into space or pulled into the sun. But sputtering isn't the only thing that affected Mercury's size. As the solar system formed and Mercury cooled down, some of the material that had been blasted away came raining back down onto the planet. Mercury grew a little bit bigger again through a process called condensation. Now Mercury is slightly bigger than it was originally, but it's not quite done growing. In addition to accretion, condensation, and sputtering, Mercury has also grown through a process called co-accretion. Co-accretion happens when two objects in space collide and stick together. This is how moons form around planets, and it's believed that something similar happened with Mercury. Scientists think that Mercury may have been bombarded by icy planetesimals early in its history, and these planetesimals may have added to Mercury's mass. That's why Mercury has so many craters. The thing that scientists think caused all of this bombardment may have been a giant planet that got kicked out of the inner solar system later on. If you want to hear more about that, check out the video I did on rogue planets. Now, after all of this sputtering, condensing, accreting, and co-accreting, Mercury ended up being the smallest planet in the solar system. But there's more to Mercury than just its size. It's actually the densest planet. This means that despite being small, it has a lot of mass. One theory for why Mercury is so dense is that it's made mostly of iron and nickel. But there's a problem with this theory.
Ice.
If Mercury was just a giant ball of metal, it would have cooled down much faster than it did. Scientists think that there's another explanation. Mercury's core is probably made of iron and nickel, but it also has a lot of sulfur, oxygen, and other elements. All of these elements combined make Mercury very dense, and that's not all. Mercury has an iron-rich mantle and crust. Iron is good at conducting heat, so it helped Mercury cool down quickly. But Mercury's heat came from more than just its formation. For the first few billion years of the solar system, it was bombarded by comets and asteroids. These collisions heated up Mercury's core and kept it from cooling down completely. This also created some of the craters that we see on Mercury today. Eventually, the solar system calmed down, and Mercury was able to cool. Today, it's the smallest planet in the solar system, but it's still very hot on the inside. Its core reaches temperatures of 3,000 degrees Celsius. That's about half the temperature on the surface of the Sun. This heat comes from the decay of radioactive elements in Mercury's core. It also comes from leftover heat from when Mercury formed. Since Mercury is so small, it can't get rid of this heat easily. It radiates the heat away, but it takes a long time. In fact, Mercury is still cooling down today at a rate of about 2 degrees Celsius every 100 million years. This will continue until Mercury's core is the same temperature as its surface. So we know that Mercury is hot, and we know that it's dense. But what about its surface? What's it made of? Well, it's made of rock. But it's not just any rock. It's special rock. See, Mercury's surface is covered in a layer of regolith. Regolith is a fancy word for the layer of broken-up rock that covers a planet's surface. On Earth, regolith is formed by weathering. This is when rocks are broken down by wind, water, and ice. But on Mercury, weathering isn't the main way that regolith is made. Most of Mercury's regolith was created by impacts from space rocks. When a space rock hits Mercury's surface, it blasts away chunks of rock. These chunks can be thrown all the way into space. Some of them stay in orbit around Mercury, and eventually they crash back down to the surface and create more craters. Speaking of space rocks, Mercury has a lot of them. It's covered in craters caused by impacts with space rocks. In fact, Mercury has more craters than any other planet in the solar system. Most of these craters are named after famous people who have contributed to our understanding of the planet. There's even a crater named after the god Mercury. This crater is over 1,000 kilometers across and is one of the largest on the planet. Mercury's surface is also covered in other cool features. There are long straight lines that stretch for hundreds of kilometers. These are called wrinkles of Mercury. They're formed when Mercury's core shrinks as it cools and the crust is left wrinkled. Mercury's surface is also dotted with smooth plains. These are made of a type of rock called basalt. Basalt is a dark-colored igneous rock that's rich in magnesium and iron. It's made when lava cools quickly. The smooth plains on Mercury are thought to have been created by ancient volcanic eruptions. But what about Mercury's atmosphere? Does it have one? Well, it sort of does. Mercury has an exosphere. An exosphere is the outermost layer of a planet's atmosphere. It's very thin, and the particles in it are spread far apart. Mercury's exosphere is made up of atoms that have been blasted off the planet's surface by the solar wind. The solar wind is a stream of charged particles that flows from the sun. It's constantly bombarding Mercury's surface and stripping away atoms. Mercury's exosphere is very thin, though. There are only about 100 atoms per cubic centimeter. To put that in perspective, Earth's atmosphere has about 1 billion atoms per cubic centimeter. So Mercury's atmosphere is 10 million times thinner than Earth's. Even though it's thin, Mercury's atmosphere does have a little bit of an effect on the planet. It helps to slow down space rocks that hit the planet's surface. It also makes Mercury look a little bit fuzzy in pictures taken by spacecraft. Mercury is the smallest planet in the solar system, but it's still a pretty interesting one. It's hot, dense, and covered in craters. It's also very thin. Mercury is a unique planet with a lot to offer scientists studying the solar system. And thanks to NASA's MESSENGER spacecraft, we've learned a lot about it in recent years. Thank you for watching. I hope you learned something new. If you did, please hit the like button. It really helps me out. Also, make sure to subscribe if you haven't already. I post videos about space and science every week. Thanks again for watching, and I'll see you next time.